here in a few minutes, but let's talk about your paper side of things first. So for today, you were to create the hello world dealy flippy thingy majiggy thing, right? Okay, and then you were to write a paper dealing with how Java compares to the other two in the big three for the programming languages. So who are our big three? Big three are Java, C#, and Objective-C. All right, so let's kind of talk about each of these in passing, and then we'll swing back on Java in the end. So C#. If you came out of school and you were going to be a C# developer, what kind of things would you be doing?
Programs based on the C++ language.
Okay, programs based on the C++ language. I think the same thing. That's the key, Microsoft. So C# is for writing software for Microsoft crap. Okay, that's C#. Okay, so C# is Microsoft specific. So if you're working someplace, you're writing business applications, or really any kind of application, and your target architecture, your target is Windows, C#'s the guy for you. And really, you could take it a step further. It's any of the .NET languages. So that could be Visual C++, that could be C#, that could be Visual Basic. Leave it at that for right now. Okay. In those same jobs, you would also probably be writing, if you were doing anything for the web, ASP.NET code. ASP.NET is a language for dynamic server-side web programming. So this isn't your typical HTML, hey, I went to a website and it looked pretty. This would be like when you go to Amazon.com, for example, and you log in with your username and password. That information needs to be sent somewhere, up in the cloud somewhere, and it gets processed somewhere and determines whether or not you are successfully authenticated. ASP.NET would be a type of programming language that might do that server-side crap in the cloud authentication thing. Okay, but specifically ASP.NET is for web programming for something called IIS, which is Internet Information Server. Synonym would be Microsoft's web server. Make sense? So this whole slide, everything about C# is all about writing software for Microsoft crap. Whether it's web, whether it's standalone applications, business games, whatever. Okay? So that's the C# world. Okay, what about the Objective-C world? Software for Apple crap. So Objective-C is the C#. Objective-C is to Mac as C# is to Microsoft. Okay? So if you were writing stuff for the Macintosh, for the iPhone, for the iPad, for the iPod Touch, you would do all of that in Objective-C. Apple also has this technology called web objects. That is their web way of doing things. It's not quite a pure Objective-C. It's some older C and C++ code as well. It's also not popular. So there is a web technology built into there on the Apple side of things, but it's not something it's something Apple uses internally. It's not something that developers externally really use. So I would probably say it's fair to say Apple doesn't really play in the web space. Okay? But Objective-C is a high-level, object-oriented, general-purpose, strongly typed, compiled, object-oriented, if I didn't already say that, modern programming language specifically for doing stuff related to Apple products. Okay? So those are the first two of our big three. Now what you were supposed to do in your paper is to explore where Java fits into the world, right? Okay, so let's look at Java. So specifically, the question was, what are the advantages and disadvantages of Java as compared to the other two? Your report is covering the role of Java in industry today compared to C# and Objective-C. Your report should include a use case describing career path of a Java developer in the IT industry. What can one expect to be doing as an entry-level Java developer? What can one expect to be doing as a senior level Java developer? What are the expectations in the journey between those two positions? Blah, blah, blah. Okay, so what did we find out? Tell me what you know about Java.
It doesn't depend on any specific platform.
Okay, platform independent. So it doesn't matter whether we're targeting Windows or Mac or Linux. Okay, so right off the bat, we have a differentiating factor from the other two, right? So Java allows us to target all those platforms at once. Okay, what else?
High security.
Okay, why? Tell me more about high security. I don't disagree. Why is it high security?
They have regular there are various steps to maintain the security.
Okay, there's a characteristic of Java that almost innately makes it more secure than those other languages. What is that characteristic? Yeah, the virtual machine. So Java is high security. It's fair to say it's high security because of the Java virtual machine. The programs actually run in a simulated computer rather than on the computer itself. So remember back to, was it one of these slides probably? Yeah, here, Java. So we have our Java source code gets compiled down to Java bytecode, which runs in a virtual machine, which then gets interpreted during runtime for the platform it's running on. Okay, so having that layer, the only things you can access on Windows, for example, a Java program is limited to having access to the things in Windows that the Java virtual machine provides access to. So if the Java virtual machine that's written by Oracle, used to be Sun Microsystems, when they wrote that program, they only hook into the operating system as much as they need to hook into the operating system to write Java software. So when us, the developers, write our Java program, the only way we can communicate to Windows is through the virtual machine. So anything the virtual machine doesn't do, we can't do. Yeah?
Would they only want to hook into as much of the operating system, like as little as possible, is that to save the rest of the memory for the actual thing?
From Oracle or Sun Microsystems perspective, yeah. When they wrote the virtual machine, you know, they ultimately want to have a minimal impact on the operating system. So when they wrote it, they only connected as much into the operating system as that Microsoft let them, is the starting point. So remember, they were kind of hampered on each platform because they had to write the virtual machine for Windows, so they could only connect in as much as Windows let them connect in. They had to write it for Apple, and you know that's another proprietary solution, probably the most proprietary of all of them. So Apple's only going to let them hook in at a very minimal level. In fact, for those of you who are Mac users, you probably see that in order to get an updated version of the Java virtual machine, your Macintosh through software update lets you know when a new one's out. You don't go to Oracle's website to download it. You have to download something that's already filtered through Apple that Apple's approved. So Oracle can't deliver it to you directly. So kind of an interesting connection there. So Apple's very, very proprietary. The most open source of them is going to be Linux, because Linux by definition is an open source operating system. But so besides the limitations the operating systems themselves are going to put on the writers of the virtual machine, the people who wrote the virtual machine, their goal was to write something that can interpret Java bytecode into equivalent code for the operating system. So they weren't going to hook into the operating system any more than they absolutely had to. So their goal was to meet a certain requirement where somebody who's writing, let's say I want to write viruses. I'm probably not going to use Java because my hands are going to be tied pretty quickly, because the Java virtual machine is only going to let me access real memory in the computer. Well, it's really not going to let me access real memory. We'll see that once we start dealing with objects. Maybe not this class, but probably next class. We'll see how Java simulates memory as a layer above your actual system's memory. So, kind of the punchline here is saying Java is high security isn't so much that Java takes extra precautions when it comes to security. It's that by definition, because it runs inside of a virtual machine, you don't really have access to anything, right? You're in a bubble. Okay, what else about Java? Platform independent. So that's the portable side. So it's platform independent. We write it once. We could run it on any platform. It's highly secure. Go ahead.
It's slower compared to like video games.
Definitely. So it's a slower language, slower in terms of performance. Why is that?
It's the sort of real-time stuff with like the actual program stuff running alongside it, trying to make it convert. Where the C++ just you run it once and then it does something.
Okay, so really, the same reason why Java is high security is also why it's low performance, the virtual machine. So this virtual machine is like this, it's this double-edged sword, if you will. It gives us a lot of security, a lot of peace of mind, but basically says you don't write video games in this language. Okay? What else? So if I'm a Java developer, what kind of stuff would I be doing what kind of stuff would I be writing? Okay, possibly web-based applications. Give me an example of well, I guess keep going with your web-based applications argument. So that's all you got.
Well, from use in that, there's Java plugins for a lot of different websites out there.
Mm-hmm.
But I don't really understand much more
Okay.
Yeah, like little applets or something.
Ah, that's the kicker. Something called applets. Java applets. How many of you have heard of those before? Okay, what is a Java applet? Now, the interesting thing here is this is the reason why Java still exists. I would say this primarily, and one other thing we'll talk about in a second. Java applet is a full Java program that runs within a web browser. This takes that platform independence argument and kind of puts it on steroids. Okay, what's cool about Java to begin with? Well, I write my program once and it will run on any platform. Well, we have to think about this in terms of when Java was created. Java was early to mid 90s technology. Okay, that's when it was coming into its own. I think most of us were alive then. Maybe not Lauren. When were you born?
97.
97. So, in any case, so during that point of time, getting software out to the masses doesn't work the way it works today. If you need a program to do something today, you hit the web, right? Google it, download the program, whatever. Now it's even becoming easier, right? Now Apple has their own app store. Windows has their own app store. If you have these smartphones, you go to the Apple App Store for your iPhone. You go to the Google Play Marketplace for your Android apps. I mean, just if I'm a developer and I want to distribute applications to the world, it's easier today than it's ever been. Okay? So before that, if you needed a piece of software, where did you go? You went to Best Buy and you bought it off the shelf. Correct? How many of you have bought software at Best Buy in the last 5 years? Might be one person who walked in and bought, Quicken or something like that. But generally speaking, that's not the way we operate anymore, right? We download it. Sometimes legally, sometimes less so. But back in the mid-90s, let's say, and this is from day one of Java, Java had this idea of an applet. And keep in mind, Java is a completely separate technology from HTML. And HTML jumped on board with this. There is an applet tag that's part of the HTML language, one of the original HTML standards. HTML is the general purpose programming language that our web browsers speak. Okay, so our web browser interprets HTML and turns it into pretty pictures and text. So built into an early version of HTML is an applet tag. So for us to embed Java programs within our web pages. So think about this. This is the mid-90s. And as a Java developer, you could distribute your software through the web. I'm not talking about emailing it to somebody. I'm talking about having somebody go to a web page and your program launches out of that web page. Well, let's think about this for a second. When did the internet, in terms of web browsing, come into its own? Similar time period. Mid-late 90s. Really mid-90s. 94, 95, 96. I think Netscape Browser was 1995 technology, I think. Remember the purple pulsing N? Now, before that was Mosaic. I think Mosaic was 93 or 92, something like that. So, Java was really born around the same time as the internet was born. Very much connected to the internet. And this idea of applets is really cool. Some of you have probably used Java applets before if you've ever gone to like Yahoo Games or something and played any of those poker games or something like that. A lot of them now are written in Flash, another kind of technology to deliver software directly through a website, but Flash is less general purpose than Java. The benefit of Flash is that it's a language built for animations. So you can make things look game-like much easier. Where Java, if you want to make it look cool, you have to kind of write that. You have to do all the heavy lifting yourself. But from a general purpose perspective, you can solve much more complex problems with Java because it's built in a much more general way rather than built specifically to write web games, which is what Flash is. So anyways, applets have been around for a long time. In fact, Microsoft loved the idea of applets, tried to steal it. So we can go back to, which slide was that? Did we have some slide Microsoft stole? Yeah, look. So look, first we tried to steal the whole technology. Couldn't get away with that. So then what did we do? Well, we tried to steal parts, parts of the technology. But I guess in Microsoft's defense, they didn't directly go and steal applets. They tried to come out with their own version of this. So Microsoft Applets, blah. They originally had something called COM, okay, which was built into Internet Explorer. That died. No good. What it eventually evolved into is a technology called Activex. How many of you have heard of Activex? Okay. What do you know about Activex? Or is it just one of those buzzwords? Isn't computer science filled with those things? All sorts of words that mean simple things but sound really cool. Like, oh yeah, Activex. I got this. What is it? What's Activex?
Directories. Email?
What you're thinking about with the directories is called Active Directory.
Okay.
Yeah, that's a whole nother Microsoft theft. Okay, Active Directory is when Microsoft liked a technology called LDAP. Stole that. No. Say this again? Say it one more time. Okay, that's what happens. Yeah, so in Internet Explorer, before it runs an ActiveX control, they're called controls, it'll ask you, are you sure you want to do this? And click OK and sign your life away and all that crap, right? But what's ActiveX? ActiveX is a program that runs within a web browser. But again, Microsoft loses. Okay? Java applets will run inside of any browser as long as the browser supports the Java Virtual Machine plugin.
Activex is only Internet Explorer.
Only Internet Explorer. So, what does that mean? That means not only can you only run it in Internet Explorer, it means you also can only run it on a Windows machine. Internet Explorer is not available for anything outside of Windows. They did a brief stint of Internet Explorer on the Mac years and years ago. That didn't last. There was about a 6-month period there where Apple and Microsoft decided they were sort of friends. It blew over quickly. Okay, so for all intent, what I'm saying is there exists a version of Internet Explorer that did once upon a time run on the Mac, but this predates OS X. This is before, this is at least 10.10 or 10.9. 10.9. Okay, so this is at least 10 versions of the Mac operating system ago. So a decade ago, minimum, when that occurred, but don't even worry about that. So let's just say Activex controls are Windows only. Even more specifically, they're Internet Explorer only. So how many of you are Windows users in here? Probably most of us, right? Okay. Those of you who are Windows users, how many of you is your preferred web browser Internet Explorer? Chrome's your, okay? So you got ahead of me. I was going to make a prediction. Pretend like I didn't hear that because I would have said this. Okay. So my prediction is whether you're a Mac or a PC user, your go-to browser, your top browser is Chrome. How many of you are Chrome users? Okay, 4.25 people. How many, I would say secondarily it's Firefox. Or if it's not Firefox, Mozilla, which is their suite. Okay? So that would be number 2. If you're a Mac user, Safari. Okay? Very, very, very few PC users would use Safari as their primary browser. Safari is to the Mac as Internet Explorer is to the PC, except Safari is significantly better than Internet Explorer is. Why do you like Chrome? Why do you think Chrome's been so popular? Passwords? Faster, okay. Why is it faster? So they're using some sort of cool space age technology? Interesting factoid. Chrome is built on top of a technology called WebKit. Who created WebKit? Apple for Safari. Interesting, maybe little known fact. So Apple, when they rewrote Safari, created a technology called WebKit that Google then repurposed. It's open source, repurposed it for Chrome. So why is it that Chrome claims to be so fast? And most people's experience is that Chrome is fast, right? Why is that? So if we were to decide, if we were to give weights to the modern day web browsers, like human weights, like like how fat is a web browser, we would say Internet Explorer weighs about 700 pounds. We'd say Safari weighs about 300 pounds. Firefox probably weighs about 400 pounds. Chrome probably weighs about 75 pounds. All of these other web browsers, they come with a bunch of prepackaged plugins. All this extra crap, all this extra bloat, most of which most of us don't use. Chrome comes completely stripped down. Okay? Basically, all it does out of the box is web browsing and like remembers your passwords. Then there's a whole bunch of hook-ins to Chrome. Because Chrome in and of itself is actually an interesting ecosystem. Just kind of going down this rabbit hole a little bit. So, what is Chrome? Most of us would say it's a web browser, right? Okay, Chrome is a web browser. How many of you have heard of a piece of equipment known as a Chromebook? This guy, Chromebook. What is that? Yeah, look, it's a laptop thingy, right? Well, it's eye of the beholder. Let's see. So Chromebook is laptop thingy, correct? That's a technical term. I'm just throwing it around there. Okay, so it's a laptop thingy. What operating system does the Chromebook run? What are our choices? We got Windows. Does it run Windows? Nope. Does it run the Mac OS? Nope. Does it run Linux? Nope. What does it run? You run Safari? Not Safari. Well, I thought you said Chrome is a web browser. I'm asking what operating system does it run? You're not wrong. It runs an operating system called Chrome OS. What we know as the Chrome web browser, in fact, is Google's next generation operating system. Okay? Google has decided, you know what? As much as the internet and cloud computing has all, become ubiquitous, can't the whole machine actually just live inside the browser? You can go out and you can get Angry Birds for your Chrome browser. How many of you have ever played Angry Birds for Chrome? It's the same game that's on the iPhone and the Android phone, same thing. In fact, go ahead.
Wouldn't that make it slower because now you're loading up the browser and stuff like the whole OS system?
Well, possibly, but instead of having all these extra programs installed on your hard drive, maybe you install some of these plugins locally. But a lot of them are streamed. You don't have to actually install Angry Birds. You can stream it in real time. Because the idea is that our internet connections keep getting faster and faster and faster to the point that, if Angry Birds is a 30 megabyte file, how long does that take? Less than 10 seconds. Who cares? Same amount of time as it might take to double click on a program on your computer to launch. But if you're not always connected to the internet, but you still want to play Angry Birds in your Chromebook, no big deal. What do? Just store it locally. That's why they have local storage on those things. So the punchline is Chrome in many ways is Google's top secret technology. I think you're going to hear a lot more about Chrome moving forward. It's kind of interesting. Google's doing this misdirection thing. Because when you think of Google and you think of operating systems, you think of Android, right? I actually think Android is their misdirection. I don't know that they try that hard for Android. The world of smartphones has really kind of caught up, and we're like, oh, there's this big war between Android for your smartphone versus iOS for your smartphone. The competition only recently has even become a real competition. Apple's product for iOS is far superior to anything Android has. Not because Apple's so much better than Google is. It's because they're solving a much easier problem. Apple is writing iOS, the software for the iPhone, for their own hardware. They control everything that's in my hand here, the software and the hardware. Google is writing Android for a zillion different handsets. One's made by Samsung and HTC and all these other things. So they're solving a much more difficult problem. So they have to write this thing to be much more generic, very similar to Windows. Microsoft always gets this bad name. Microsoft is solving a really difficult problem with their operating systems. They're writing Windows to run on 1 million different computers. The Mac OS runs on only computers Apple makes. Like 9 computers, all of which they control. So it's kind of interesting. But Chrome, I think, is really coming in under the radar. It's I think they're making a move for this being the next generation technology for computing. And it's kind of proving something that Microsoft is currently doing as being at least somewhat interesting. Most people would say Microsoft is not cool, correct? Google, cool. Microsoft, not cool. Just cuts, right? All right. I mean, Microsoft used to be cool. Not cool anymore. They're not the cool kid. What is Microsoft? What's their new technology now? Microsoft has these, you see the commercials for them, these Surface tablets, right? What is a Surface tablet?
Run Windows 8 RT.
Okay. Or the professional one runs Windows 8, the real Windows 8. The problem Microsoft's trying to solve. So Microsoft, they want to compete with the iPad, right, and Android tablets. Well, Apple has created this division. they've said, okay, well, here's the iPad. The iPad is an operating system that is a touch device only. So everything you accomplish on here is for fingers and toes. You use your iPad with your toes, don't you? Or is that just me? It's just a me thing? I mean, sometimes you're eating, you know. So anyways, Apple has separated those two. They have a mobile product line that everything is about touch-based. Then they have their desktop, laptop line, which has an operating system that they keep evolving with some things they've taken from iPad. You know, like they like this idea of being able to swipe between screens, and you know, this is iPad-y, this kind of stuff. Okay, so they take something out of the book of iPad, but this is still a mouse and keyboard-based operating system. iPad is not a mouse-based operating system. It's meant fingers. Okay, Microsoft has taken the position with the Surface that, you know what, we really love this idea of touch interfaces. Clearly, it's better for many, 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 many things, but it's not better for everything. Okay? Most people who are, let's say, most technologists, they have a need for both of those devices. iPad covers 90% of what they do on a daily basis. You know, and if you don't need a screen that size, your smartphone covers 90% of what you need. Okay? But it's that last 10%. Your accounting software that you really need that precision of the mouse. Or if you do a lot of spreadsheet stuff. There's some cool spreadsheet software for iPad, but if you do a lot of spreadsheets, you want the mouse. It just makes your life easier. Well, so with Apple, they say, oh, buy our iPad and also then go and buy your $2,000 laptop from us. Well, Microsoft says, with our single Surface tablet, you can do your tablet stuff whenever you need to do tablet stuff. And then when you do need to do your accounting software or something like that, you plug the mouse into it. Now you're running the same operating system. Windows 8 was designed to be a touch and mouse-based operating system. So now you plug the mouse in, you can start using it, and you can load your, QuickBooks or whatever your accounting software is or something like that. Couple things they haven't quite figured out yet. She mentioned something called Windows 8 RT. So there's two versions of the tablet, the Surface, the Microsoft Surface rather. The Surface RT runs Windows 8 RT, which is a new version of Windows 8 written from the ground up for a new kind of processor. Well, it's not really a new processor, but it's more recently come into its own, called an ARM processor, ARM. That is, it's not an Intel processor. Okay? So that means that just because you have a Surface tablet running Windows 8 RT, if you want to install QuickBooks on there, you can't. Because QuickBooks was not written for the ARM architecture.
So can you run QuickBooks on a Chromebook?
No, very similar problem.
And how?
You can do QuickBooks Online, their web-based one.
Yes.
Yep. But you couldn't do their standalone application. So both of these technologies are reliant on people writing software for them. So Microsoft's fix for this is their Surface Pro, which is expensive and horrifically underpowered with terrible battery life. Have I sold you on this product yet? Okay. But it will run QuickBooks or any other Windows software because it's basically a Windows laptop disguised as a tablet. And because it's a tablet, you can only fit so much battery in there. You can only fit so much horsepower in there. You put too much more stuff in there, it's going to make your hands catch fire because it'll be giving off so much heat. So it's not as good as it could be because technology doesn't let it be as much of a machine as it needs to be to run on the old stuff. So really what Microsoft is banking on is it's banking on places like, QuickBooks and other places writing their software for the RT version of Windows 8, the ARM version, saying, hey, join us in this idea that sometimes your software makes sense on a touch-based with a touch-based interface, but sometimes it makes more sense with a mouse. And in that situation, if you write it natively for our new version of Windows, this Windows RT, which looks just like the Windows 8, but it's under the hood, it's written for a different architecture. If you write it for that, then it will run on this lower cost, lower powered, longer battery life, but still fast feeling tablet that is the Microsoft Surface RT. That makes sense? So Chrome, which all of us just believe is a web browser, is really flying under the radar. Because if you open, I think I have Chrome on here, don't I? No, I don't. But in any case, if you open up Chrome, the main page takes you to the Chrome store, right? You can browse all these applications that run inside Chrome. Angry Birds is on there. There's accounting software. There's a zillion different programs that you can install in your Chrome. And all of them allow you to log in with your one Google login. So you just click log in with Google. So you have your Gmail account or your Google account, you're just in. So underneath everybody's noses, Google's created this empire that is the web browser-based operating system. It's fascinating. It really is a fascinating thing. I don't know if I buy into it at this point because it is reliant on a lot of moving parts. It's reliant on this idea that other companies jump on board. So Chrome OS is only going to be as successful as people write Chrome software, write useful things for Chrome. And you probably, if you follow Chromebooks at all, one of the newer released Chromebooks has a touch screen. So it looks like a laptop, but you can actually touch the screen too. And Apple says that won't work, but I don't.
Does Flash work on tablets?
Flash, actually, that's an interesting thing too. It will run on the Microsoft Surface because that's just running Windows. In the early days of iPhone versus Android, people who are Android fanboys used to say, oh, well, we have Flash. How many of you are Android users now? Okay. You don't get Flash on your Android phone, do you?
I don't know.
Won't work.
No, because I couldn't do my mastering physics homework on my phone.
Doesn't work. But it was interesting. In the early anti-Apple, anti-iPhone commercials from Android, they would always talk about, oh, and by the way, we can actually load all web pages using mobile Flash. Where Apple always said, no, we won't let mobile Flash in our platform. Why? Because it's garbage. The mobile version of Flash was a horrific program. It was written for something that was not running off of a battery. So, and you can even see this on laptops. Flash is a very old technology that did not update well. We really rely on something. It's kind of like the old power grid or the old POTS telephone system. You know, we still use these things, and they're left over from like years and years and years ago. If you have a laptop and you don't plug it into the wall, and you go to some place that has a Flash game, your battery will just get destroyed playing that Flash game on in a web browser. Just even leave it sitting there, because you know how the game just does its own thing, you know, with the credits and crap like that. You'll get like 40 minutes of battery life on something it should get 7 hours. Burn through your battery because Flash is a heavyweight application that they tried to squeeze into a web browser. No big deal if you're tethered to a wall, right? No big deal at all. Who cares? What's electricity? Well, it just costs money, right? It's growing on trees, no big deal. So, but kind of the interesting thing is in the early days of Android versus iPhone, or Android versus iOS, the software that runs on iPhone. All the Android commercials like, oh, we have Flash, you don't. And very quietly, they just discontinued Flash and then stopped talking about it. It's like, you know what? This is horrible for our battery life. And by the way, when it does work, it looks like garbage. So even when Flash was on Android, it barely was functional because of how heavyweight Flash was. So they just got rid of it. So then for a while, it was Android had multitasking when Apple iPhone did not have multitasking, right? So clearly Android was better than Microsoft, right? Once again, Apple made the right call there too. So Apple said, we're not going to do Flash because it sucks. We're not going to do multitasking yet because we don't know how to do it. And that's an important thing. Android is a mobile operating system built on top of a desktop operating system technology called Linux. So Android is built on top of something called Linux. And Linux has a great multitasking model. Nothing wrong with it. But Linux computers are built to be plugged into a wall. So that multitasking model did not take into account that you're running off of a battery. So when you use your smartphone and you launch 30 different applications and you put them in the background, well, how often do you go back? I mean, we all have those 2 or 3 apps we look at all the time, right? We want those to be quickly pop back up and that kind of crap. But some of those other 30, we opened it for a second. Maybe we check it once a month. Maybe we accidentally opened the weather app. And we can just look outside and see it's freezing, right? So, now the funny thing is, how long have you been an Android user? You're an Android user. Who else in here is an Android user? How long have you guys been Android users? 2 years? Okay, that might not be long enough. Longer? Shorter?
I never use iPhones.
Okay.
I've only used like the laptops. I've used Macs since sophomore year.
Okay. So how long Android though? Are we at least 4 years? Do you remember the days when some of the most popular apps, back then it was called the Android Marketplace, some of the most popular apps were apps to close other apps? Top sellers on the Android Marketplace was apps to kill other apps. Because it was not common knowledge that if you did not want your application to continue to run in the background, you had to go and physically shut down that app. But because Android's multitasking model was based off of a desktop computer, which didn't take battery life into consideration, you had an app that you can launch that allowed you to quickly kill off any apps you weren't going to use to prolong your battery life. That make sense? So, this was another mistake Android made, in my opinion, because for a long time they got a really bad rap for battery life. Then they just kept coming out with bigger and bigger phones with bigger and bigger batteries, claiming they had longer battery life than these smaller iPhones. Well, I mean, I could strap a car battery onto my back and hook it into an Android device. I can get pretty good battery life. But, point is that the way Apple solved their multitasking thing is by doing something that really isn't true multitasking, by most uses of the definition. When an application on an iPhone goes into the background, or an iPad for that matter, when it goes into the background, that application chooses whether or not something in the background makes sense for it. So, for instance, a good example would be like Pandora. Pandora is a music application. Before Apple had their, quote, multitasking, if you wanted to listen to Pandora, you had to have the Pandora app open. Now, when you put Pandora into the background, what happens? The Pandora app becomes the people who wrote it, their program becomes aware that, oh, I'm being put into the background. Do I need to do anything under this special circumstance? And the Pandora app knows, okay, I need to register my audio with the operating system's audio. So what Apple did is they opened up about 8 different hooks in the operating system that applications in the background could take advantage of. So the application in and of itself is not running in the background. Only a little tiny portion of it is running into the background, and it hooks into the operating system in one of these 8 places that Apple has opened up. So Pandora, when they go into the background, what does Pandora do? Pandora says, keep playing my audio through the operating system. The rest of the Pandora app is dead. Just keeps going, keeps playing the music. That make sense? So what Apple did is they minimized the amount of horsepower that's being used in the background by allowing apps that could run in the background to only utilize the aspects of the phone that make sense for it, and other apps that it doesn't make any sense to run in the background don't do anything. If I open up the Weather Channel app or something like that, it doesn't make sense for that to run in the background. So when I move to a different app, that's using 0 processing power. I can just quickly switch to it through my app chooser thingy. So that's how Apple solved that problem. And then people said, well, but when you have programs running in the background, then they can let you know when something has occurred. For instance, on your desktop computer, if you start downloading something, a 5 gigabyte file in the background, you might have a little bell that goes off at the end when it's done. Okay, well, how did Apple solve that? Through push notifications. So the application becomes aware in the cloud, not using your battery life, that something happened, and it pushes that notification to you. So all that computing is hooked into non-battery related stuff and then comes back down to your device. And now Google uses push notifications as well. It's the right way to solve those problems. So it's nothing taking away from Android. Android had to do something to set itself apart from Apple and also had to play catch up. Android hit the market about 2 years after Apple hit the market. But it's very interesting when you look at these different technologies and you start seeing how their thought process goes, and you can try to make some predictions about what's coming next. So I don't know. I might say keep an eye on Chrome. I'm not necessarily a fan of the browser. I don't have a problem with it. I just don't really use the browser. But I don't know. I really think Android is Google's misdirection. I think the eye and the prize is Chrome. It's my gut feeling. We'll see, especially in education. You know, I think Chromebooks in the classroom, at least today, maybe make more sense than iPads in the classroom. First, from a cost perspective, maybe also from a durability perspective, and also from an antiquated perspective. Every year there's a new iPad coming out, and you could probably go a couple of years without getting the new one and still be okay, but they keep getting faster and faster and faster. Well, web browsing really hasn't changed that much in a while. You don't really require that much horsepower to do stuff inside of a web browser. And it's a pretty tried and proven technology too. It's been through the ringer. Does that make sense? Okay, so that was an interesting rambling, but good crap in there, I think, maybe. So, in any case, we were talking about applets and how Java or Microsoft tried to tried to duplicate that technology through something called Activex. The limitations of Activex are that you have to be running Internet Explorer on a Windows machine. Well, you have to be running Internet Explorer, which means that you have to be on a Windows machine. It's the punchline there. One of the problems with Activex is, first of all, security issues. This isn't necessarily because Activex is a garbage technology. Part of it is that there are far more far more known security holes in Internet Explorer than there are in other web browsers. Why is that? Is it because Microsoft sucks and can't write good software? Okay, been around longer is probably a true statement. Actually, I don't know. Internet Explorer it has not been around longer than Firefox, really, because Firefox used to be Mozilla, which used to be Netscape. And Netscape predates Internet Explorer. So why are there more known security holes in Internet Explorer? Go ahead, sorry. Actually, shouldn't that make it more secure? If they only have to focus, you only need to make it work on the operating system that you wrote. We took the poll in here, I don't know, a half hour ago or however. I get off, by the way. Oh, so somebody stop me if we get around 8 p.m. or something and I seem like I'm going. That's kind of when I want to take a break. So at least, I don't know what time it is 3/4 of the time. I go in these little zones. So in any case, yell at me and I'll try to come to a stopping point so you guys can, go to the bath. You can go to the bathroom whenever you need to, but I'll have respect for you if you go in your pants. It's supposed to be a joke. I saw him back there. It's like, I already did, man. All right, so we took the poll a little bit ago about, which web browsers we use in here, and kind of Chrome is our popular one amongst technology-aged folk, right? And you. Firefox is up there. Safari, probably really just Mac users, but your two top browsers are probably Chrome and Firefox across the industry for people who are technology people. Technologists, I usually just refer to them. But if we went into a shopping mall and we took a poll, you'd find that Internet Explorer is by far the most popular web browser. By far. Why is that? Well, because Microsoft Windows by far is the most popular desktop operating system, right? Really, now we really have two different ecosystems. We have desktop computing and we have mobile computing through our phones and tablets. You know, phones and tablets, Safari is easily the most popular web browser because iPhones and iPads make up a very, very large percentage of the web traffic from smartphones and tablets. A huge percentage. But obviously, our internet traffic coming from desktops is going to be 93% from Windows, correct? And the people who are using Windows are not all technologists. And from their perspective, what is it? The way I access the internet is by double-clicking on the blue E. That's Internet Explorer. That's what the guy from the Geek Squad at Best Buy told him to do. So Internet Explorer is by far the most popular web browser. By a lot. I think it's not even close. So given that, if a few minutes ago when I was talking about Internet Explorer having the most known security holes, part of that's because people are most looking for security holes in that browser. You know, just like Microsoft. How many of you know somebody, so like an Apple fanboy, or maybe I can get somebody to admit to this in here that you are one of these. Have ever used the argument that, oh, Apple, the Macs don't have viruses, Windows have viruses? Heard that before? You've never heard that before? That Macs don't have viruses?
It's like that little phrase that everyone uses to defend their MacBook.
Oh yeah, that's the Mac fanboy thing. It's like, oh, you know how you have to have your virus protection? You got three different kinds of virus protection things on your PC. I don't even use virus protection on my Mac. They don't even make it. Macs don't have viruses. Never heard that. Most of you have heard it, right? You think it's true?
Fangirls.
Huh?
Yeah, fangirls.
Fangirls don't exist.
No, fangirls are.
No,
Fangirl is a different term for a completely different topic.
that's it. Yeah, even females fall into the fanboy category. It's a sexist comment, but it's a true comment. But in any case, I could probably, from an operating system perspective, make the argument that the Macintosh operating system is a more secure operating system than Windows by less than 10%. And that's by nothing that Apple's done, because Apple stole their operating system from good stock. Okay, Apple stole the Mac OS X operating system from a Unix-based platform called OpenBSD. That's been around for years and years and years and years and years. It's a Unix-based operating system. Because before OS X was OS 9 and OS 8 and OS 7 and OS 6, and those were all garbage. I had a Mac back then. One of my hobbies when I was in school was having machines of different operating systems all talking to each other because they all hated each other, even at the hardware level. Macs and PCs did not get along. So figuring out interesting ways to make all those computers talk to each other was a hobby of mine. So in any case, Apple was easily trailing Windows from a stability perspective. It was not uncommon at all for me to wake up in the morning, turn my monitor on my Mac, and see that the mouse still moved around the screen like this. Yet the clock up here would say like 2:13 a.m. You know, that's the point in time when the operating system died. So now I just have a solid picture with a moving mouse. And I had to hard reboot the machine. So Apple's operating systems were not all that great before OS X. So then they went out and they said, hey, you know, we have these really good operating systems out there called Unix. And here's one called OpenBSD, which is an open source Unix, which means we can steal it and they can't sue us. Great. But, you know, we're Apple. We're supposed to be cool. So what are we going to do? We're going to make a pretty front end for this thing and make it look like an Apple product. We'll call that Aqua. And then we'll name the operating system OS X. Well, does the X stand for 10 because our last operating system was OS 9? Or does the X stand for the X in Unix? To this day, we'll never know. You know, but then they stuck with that because now In fact, actually, they maybe even just gelled those two together. If you look in here about this Mac, I'm running the latest version of the Mac operating system, and it's OS 10.9. So the OS X, seems to be OS 10, but this is a 9th iteration. So they just held on to the X thing for almost a decade now. The first bunch of versions, they named it after cats. They had panther and tiger and leopard and snow leopard and lion and mountain lion. And then Apple at last year's Worldwide Developer Conference made a funny joke. Apple doesn't usually make jokes, but they made a funny joke. So they were up there like, what are we going to call our next operating system? We're starting to run out of names of cats. So, we have lion, then we had mountain lion. Maybe the next version is OS X sea lion? And they show the sea lion bouncing a little bouncy ball thing. So they decided to abandon cats. Anybody know what the new version of Mac operating system is called? Mavericks. Mac OS X Mavericks. It's actually based out of, I think Mavericks are what they call the waves off the shore of San Francisco. So I think they're starting to use naming conventions dealing with the San Francisco area. Apple's in Cupertino, which is a western suburb of San Francisco. Same thing. I'm pretty sure that's what I know it refers to. I think it has something to do with the waves off the shore. I think that's what they call them, as the Mavericks or something. But in any case, I can make the argument that the Mac operating system might be a little more stable than Windows, or a little more secure than Windows, strictly because they took it from an operating system that's substantially more mature than Windows is. Unix has been around for 40 years. Okay? Windows 8, Windows 7, Windows Vista, they're all based on an operating system called Windows NT, the NT kernel, which came out around year 2000. That's actually a lie. Came out around 96. Yeah, say that. Early stage Windows NT was 96. The first one that worked was 2000. Windows 2000 was the first NT-based operating system that people liked. And then they merged the two together, their business and their consumer lines. That was when Windows 98 then became Windows ME, then became Windows 98. And then they merged 2000 and 98 into XP. So in any case, Activex kind of failed. I mean, it still exists, but because it was so platform dependent, it was very difficult to deliver. For a good example here would be QuickBooks. QuickBooks had an Activex version of their software that was delivered through Internet Explorer. But what they just did is they limited the customers to only use PCs running Windows because they had to have Internet Explorer in order to use it. That becomes problematic, especially when you consider that business applications don't need the performance that a C program gives. Java is perfectly sufficient. So why would somebody, if I'm writing a piece of software that I want to deliver through a web page, why would I write it in anything but Java when Java lets it run on all the browsers, regardless of whether you're on Windows or Mac? So Activex was kind of bound to fail because of that. Microsoft has done a lot of really great things, but they play in their own sandbox, right? They have to live with the ecosystem they've created. By being proprietary like they are, which is fine, they are limited to that, and the world has expanded a little bit beyond Microsoft. In the desktop market, not tons beyond Microsoft, but at least a little bit. Okay, but certainly in the browser world, it's not only Microsoft. It's across the board, whether you're talking about tablets or smartphones or desktops for Mac or PC or Linux or any of these things. So you have a huge world of people that are using web browsers to experience mobile app or just experience applications. And the way to deliver that the best is through Java because it works. You write it once and it works for all of them. Okay, so back to this Java slide. Why was Java so successful? Biggest reason, well, not even so successful. I think you can even answer this question. Why does Java still exist today? It's because of applets. I think this plays a very, very large role. on why Apple did not die. Because frankly, you do not see very many applications, desktop applications today, being written in Java. Sometimes you have little utilities, things like that, that somebody might write. Like for instance, when my company writes software that we want to put onto somebody's computer to talk to some server, we might write a little widget in Java to throw onto some different machines because we don't have to worry about what they're running, Windows or Mac or anything like that. But those are very, very platforms are very, very domain-specific little tools. You don't see places releasing software that are Java-based programs. Yeah.
So are the vet programs, like from that Colorado website, you know what I'm talking about?
Mm-mm.
It's like using physics. I was wondering if those are Java. I was wondering if those are actually in the browser or on the computer.
I would almost guarantee they launch out of the browser. There's a way an applet can disconnect from the browser and look like it's a running application on your machine. But I guarantee it's launching out of the browser. Because you're not installing it on your machine. You go to a web page, click something, and the program launches.
It has the option to run and to download.
Okay, yeah. So you can run it locally if you want using your own Java virtual machine. But they're at least distributing it through a web page. So I guess in that case, it's kind of both. You can either just run it from the web page or bring it locally so that you don't have to have an internet connection to run it next time. So applets are a big reason why Java still exists. Because that was the best way to deliver high-performance business applications through a web browser. And really, there's one specific domain that has probably been most profitable. And it's because of where the money is. How many of you have ever traded stocks, played the stock market at all? Okay, well, we've heard of day traders and stuff like that, right? The professional stock traders, they wake up 45 minutes before the market opens and they read all the news and stuff like that, and they're sitting there at their computer ready for as soon as the market opens, they start losing all their cash, right? Yeah, that's their goal. Well, for a professional trader who is needing to make real-time trades and see all this information, charting and real-time graphs and all this other crap, there are professional stock trading applications. Any of the websites that you might go to that are trading platforms like E-Trade, Thinkorswim, Ameritrade, any of those, they're all going to have their professional trading platform. You can buy and sell stocks just through their webpage thing, when it's not really dependent on real-time transactions and stuff like that. If I'm buying 100 shares of some mutual fund, I buy it at the price it closes at today, which might be 6 hours from now. Doesn't matter if I push the button now or 20 minutes from now. I'm agreeing to buy it at whatever price it finishes today. But if you're somebody who's buying, thousands of shares of Google, and it's very important that it happens within this 3-second period or something, they have these trading platform tools that you might, depending on how big your account is with them, they might either charge you $100 a month for your subscription to it, or they might just give it to you if you have $1 million in your account or something, But in any case, all those programs are Java-based. So they wrote these, highly sophisticated, full-blown trading platform applications that will span across multiple monitors. If you look at some of these stock traders, you see them in the movies and stuff like that. They're sitting there, they've got 5 monitors around them, and they got stuff up here, and they're seeing the news feeds, and they got this other crap, and whatever it is. This is a Java application that's spanning all these screens that launched out of a web browser. And millions and millions and millions and millions of dollars every single second, every single day of the working week is attached to Java programs as they're buying and selling stocks. It's kind of an interesting, so a very small percentage of the population, but a very high percentage of the dollar amount that's flowing through Wall Street. It's kind of another interesting factoid. So applets were really Java's godsend. Secondarily, the other reason Java still exists is a company called Google. So, who was Google's biggest competitor? It was Microsoft, right? Google hated Microsoft. You ask Google, do you hate Microsoft? No, we don't hate Microsoft. Google historically has been named one of the top companies to work for in the world. They're usually in the top 3. When you get a job at Google, they give you a choice what kind of computer you want on your desk. Would you like a Mac or a Linux machine? That's the end of the choice. No, but we like Microsoft. They're not going to give you a Dell. They might let you install Windows on your Mac if you have to do some Windows development, God forbid. Because one of the cool things Google does is 1 day a week, Google pays you to work on whatever you want. So 4 days a week, you work on whatever your boss there tells you need to work on. 1 day a week, you come in, they pay you to work on whatever project you want to work on. Google just gets the first right of refusal to buy your technology. Not take it, buy it. So plenty of really cool applications, really cool companies have been grown out of Google. And some of them, Google made an offer to buy the company for, $100 million or something, and the people went out and did it on their own. Even Google was born out of that idea. Google, the founders of Google, were PhD students at Stanford, and they were working on an idea for search engine technology. And they decided, hey, this is so good, we should drop out of school. 2 reasons. Reason number 1, well, we need to have time to work on this. Reason number 2, if they submit this search engine technology as their dissertation for their PhD, Stanford owns it. So, drop out of school, create Google. Billions of dollars later, seemed to work out. But in any case, Google adopted Java. They became a Java shop. So, internally, Google was not using Visual Studio, Microsoft's languages. Google was not using Objective-C, Apple's languages. At the time, they definitely hated Microsoft worse than Apple. Now I think they all hate each other. Because now you have Google. I think they just hated Microsoft since day one. Because they just believe in different things. Google is a very open-minded, open source type company. Microsoft is not. Google and Apple actually were pretty good buddies prior to the Android iOS competition. Because there was actually several board members on Google's board from Apple and several board members on Apple's board from Google. And they kept having to recuse themselves from board meetings because they were talking about strategic things dealing with the mobile operating systems that could benefit the other company. It was a conflict of interest. So I don't know if there was ever true hatred that came out of that, but certainly they were playing in enough of the same spaces. It didn't exist in the early days where Google's a search technology place and Apple is a hardware innovation technology place, and they kind of just, hey, we both are pretty good at what we do. When they started sharing enough of the same space that it became difficult to be on each other's boards, and I think there was some animosity that came out of that. But, this is really the punchline of why these 3 languages have remained the big 3. Kind of make sense? They each kind of have their place. C#, really, really, really strong as long as you're doing Windows crap. Objective-C, really, really, really strong as long as you're doing Macintosh crap. Java, really, really, really strong. Horribly mismanaged by its inventors. Sun Microsystems really failed. They did everything they possibly could to make Java fail. It's talking about the stock market. The ticker symbol for Sun Microsystems when they were still a company was Java. If you were to buy stock in Sun Microsystems, you were buying the ticker symbol Java. They never found a way to monetize it. They never made money off Java. They created this incredibly flexible technology that everybody was adopting, but couldn't figure out how to monetize it. And moreover, they also never figured out how to bring it all together as one cohesive development environment. There was never a Java equivalent to Microsoft's Visual Studio. So Microsoft has a development package called Visual Studio, which has C# and C#, C++, Visual Basic, and ASP.NET built into it. But it's one software package where you can use all those languages and all the technologies involving those languages all kind of meld together, all under one roof. Java had like 50 related technologies, all individually packaged. So if you wanted to use Java Beans, which was another technology, you had to create an environment specifically for doing that. You couldn't use the same environment you were using to write your Java software. You had to create a new environment for doing it. It's just a headache. So they just did everything they could to make it fail. But Java today is highly reliant on a lot of the technologies that other people are using. For instance, every single Android app that anybody has ever downloaded, including Android itself, had to use the development tools provided by Oracle, which used to be Sun Microsystems. You write every Android application, you write Android applications in Java. So without Java, Android does not exist. Moreover, Android applications do not exist. So Google is reliant on Oracle, company that owns Sun Microsystems, to continue supporting Java. Because if they decide to pull the plug on the Java software development kit, millions and millions of Java developers who are currently writing Android applications can no longer write Android applications. Google doesn't control that. Apple controls their ecosystem. You know, just interesting technological world we live in today. So clearly everybody hit all those points in their paper. So, I don't know. I think it's a pretty interesting topic and something that, you could really see where each of these technologies have thrived, where they've been challenged, and how even through, all of them making every effort to fail have somehow succeeded. Every single one of these companies involved here, Apple almost failed as a company, right? They fired Steve Jobs, hired the Pepsi guy to run the company. Famous quote, do you want to change the world? You want to sell sugar water the rest of your life? Well, 6 months later, that same guy who came to be the CEO of Apple, fired Steve Jobs, almost ran the company into the ground. Steve Jobs came back, funded the company out of his own pocket, and somehow saved face. This is all during the time where they were riding the Objective-C horse, hoping that was going to work out. Microsoft almost lost everything when they tried to steal Java. I mean, Bill Gates did not step down from being CEO of Microsoft by choice. It was a political move because of what was happening in the court system. He had to distance himself from the company to save the company. You could make the argument Microsoft was too big to fail, but I'm not sure that was really a truth. And we just talked about Java. All right? So, given all of that garbage, let's see what are we doing here. Remember back from our slide last time, well, I got to find the slide, but it's one of these guys. There we go. How human beings solve problems. Well, we use our memory. Programming languages have a job of simulating the way we solve problems. And one of the ways they do that is through variables. We talked about variables last class. Talked about all the primitive types. What's a primitive type? It's a type that's built into the language and only can hold a value. The limit to what it can do. We should have a slide somewhere here that says there are two types of variables. Right there, two types of variables. Primitive type variables, a variable type built into the language which is only capable of holding a single value. And then an object type variable, which you really haven't talked about yet, but they're kind of like super variables. They can do more than primitive types. They can hold more than one value if you want, and they can potentially do more. I'll say no more at this point. So that's what variables are. Variables are named locations in memory that we can store values. So we talked about all those primitive types. We talked about the signed and unsigned and the whole Y2K bug, that kind of crap. We talked about bits and bytes and gigabytes and terabytes and all that garbage. We talked about converting numbers, binary. We talked about how do we define variables in our language. The generic syntax is the type, because Java is a strongly typed language, followed by the variable name, followed by optionally the value. We saw some examples of numeric operators, plus, minus, times, divide. Then we had the modulus operator for third grade math doing the remainder of an integer division. Talked about Boolean expressions. Boolean expression is any expression that boils down to a single value of true or false. We talked about our Boolean operators, used your arithmetic Boolean operators, less than, greater than, blah, blah, blah. We talked about the logical Boolean operators, ands and ors. We looked at a bunch of examples of Boolean expressions. Talked about character sets. Specifically, we talked about character sets as it related to the char primitive type. Char primitive type being a 16-bit unsigned integer. That's 0 to 65,535 to represent the Unicode character set. Double-click to edit. We talked about that. So we looked at some variable definitions here. Int a equals 5, int b equals a plus 2, that kind of crap. We looked at if statements near the end of class. Okay, so this was the second way human beings solve problems. Memory, that's done through variables. Asking questions, that's done through conditionals or if statements. Okay, so the syntax for an if statement is the word if, followed by a Boolean expression, followed by an opening curly brace. This is the block structure. Have the logic in here that you want to do when something is true. Optionally, you can have an else, block structure, logic when something is false. And we had an example of this. So if we have some variables, a equals 6, b equals 7, c equals -1. If a is less than b, is that true? Is 6 less than 7? Yes, it is. So we'll say c is equal to a times 2. So when this is done, c is 12. Okay, so that was an example of an if statement in action. So where we ended last time was getting ready to talk about repetition. So this is the third way that human beings solve problems, through repetition. In most programming languages, these are called loops. Okay, we have something called loops. There are 3 kinds of loops. That sounds like a fun new slide, right? There are 3 kinds of loops. While loops, for loops, and do while loops. Okay? Each of these loops lends itself to a different type of problem. And we'll talk about those here in a second. Now, having said that, though, you can solve any problem that involves loops using any of the 3 loops. Just each loop kind of lends itself to certain problems. All right? While loops lend themselves to problems where we do not know how many times we need to repeat something. An example of that would be press any key to continue. How long will it be until I press a key? Might be a second, might be an hour, might be never. So a while loop would say, has he pressed any key yet? No. 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 Over and over and over again until I finally press a key. So a while loop lends itself to doing something some number of times, but we don't necessarily know how many times we need to do it. Okay? And we'll look at each of these in terms of their syntax and stuff, but I'm just giving the high level of what each one's for. For loops lends itself to problems where we know how many times we need to repeat something, or counting type problems. Do something 10 times. Well, that would be a for loop. I know exactly how many times I need to repeat. I need to repeat 10 times. That doesn't mean you couldn't do it with a while loop. We'll see examples of both. But for loops lend themselves to that. Okay? Now, both of these guys, while loops and for loops, are something called pre-check loops. That is, the Boolean expression gets checked before we execute the body of the loop even once. Do while loops. And again, 2,000-foot view, you'll see exactly what I mean by that. All right, so do while loops. These lends itself to problems where we need to repeat something at least, well, not repeat, where we need to execute something at least one time. All caps. At least one time. And this is a post check loop. So while loops and for loops are very similar in problem solving. Do while loops, that's the outsider. But they're very important. So do while loops involve doing something at least one time. Where while loops and for loops, we have set ourselves up to do it more than once, but there's no guarantee we will even do it one time because it's a pre-check. We ask the question before we execute the body of the loop. With do while loops, we execute the body of the loop first, then we ask the question. So whatever we're repeating, we will do it at least one time with a do while loop because it's a post check loop. We will do it 0 or more times with while and for loops. So do while loops lend themselves to problems where we need to do something at least once. These are rare in terms of the number of problems that exist like this, but they're very common in terms of how often this comes up. Not really in programming, but a good example would be authentication. Every single day, whether we have the password stored or not, we are authenticating with something. So let's say you go to check your email. You must provide your username and password at least one time in order to check your email. If you get it wrong, then you'll have to do it over again. But it has to be presented at least once. So you're asked for your username and password once, you put it in. If you got it right, great. If not, we'll ask you again. That's an example of where a do while loop would come in handy, where you need to do something at least one time. Does that make sense? All right. So in terms of commonality writing software, the most common loops you'll see are probably for loops, followed by while loops, followed in a distant third by do while loops. Do while loops are far, 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 far less common. All right. So that's our high level view. Any questions about those three different kinds of loops at that level? Okay. So let's look at the syntax. So a while loop. While, open parenthesis, Boolean expression, close parenthesis, opening curly brace, logic to repeat as long as Boolean expression is true, closing curly brace. That's the syntax for a while loop. So it's the word while, and Java is a case-sensitive language. So that means while must be all lowercase here. Okay, Boolean expression, this is any expression that boils down to a single value of true or false. You all promised me you were experts in that last class. Opening and closing curly brace, this is the same opening and closing curly brace as we see in if statements. This is called a block structure. Something we'll see through practice is this is not actually required. Pretend like you never heard me say that. It's never wrong to put an opening and closing curly brace. Technically, what does a while loop do? It executes the next statement 0 or more times. Well, sometimes you don't quite understand what a statement is. When you're done with this class, you'll know what a statement is. But if you only have one statement, you don't technically need to put curly braces around it. But a block structure like this is in itself a statement. So anything you have inside the opening and closing curly brace will be executed as long as the Boolean expression is true. So it's never incorrect to put the body of your loops or your if statements inside of curly braces. Therefore, I would say always do it until you know better and decide, I still do it. And I promise you I know the difference. Okay? So, I include the opening and closing curly brace as part of the required syntax, even though it's technically not. So that's a while loop. I'm going to steal that block here for our next slide.
Be the next Microsoft.
Who will be?
I was joking because you said I was going to steal it.
Oh, I get it. All right, for loop. Actually, before I do a for loop, let me go back to this while loop here. So that's the generic structure. Let me show you something that prints out the numbers between 1 and 10. Okay, that way we can look at equivalent examples between these. So I'll put the code after this. So I'm going to say int I is equal to 1. While I is less than or equal to 10, do something. What am I going to do? I promise I typed. See, that's where the beach ball happened. They had named it Sea Lion. This was the beach ball. Be patient, my poor little Mac is very sick right now. It's actually permanently sick. Wonder when the last time I hit save was. Spaces don't matter. It occurs to me that me saying spaces don't matter is only mostly true. I'll answer it by example from the question you just asked. So what did I lose? I didn't lose much. Ha! Look at that. Thank God for autosave. All right, so we'll say int I is equal to, what did I say, 1? So, for instance, there must be a space in between the int and the I. You can have 30 spaces in there if you want, but there must be one space. You can't run those words together. Okay? This space is optional. This space is optional. You can have as many spaces as you want. Well, don't put those characters in. You can have all these spaces in here that you want. No problem. Nobody would ever do that, but Java doesn't care if your entire program's on one line. One of the classes I teach this semester is it's Computer Science 450. It's our compilers course. So we learn how to write the Java compiler, the thing that takes source code like this and turns it into. So one of the things we're working on right now is writing the parser, the thing that reads in your source code like this and figures out what all the tokens are. So it ignores white space. So from its perspective, the most efficient way to writing this is with no spaces. So from a compiler's perspective, that is the most efficient way of writing that line, because it doesn't have to skip any white space, because I didn't include any white space. I don't think there's a space in there yet. No space in there. That makes sense? This isn't considered white space. That is white space. It's a single white space, and it's required so that it can read in the word int as a token and then I as an identifier, the variable name. Make sense? Okay. So int I equals, I usually space it like that, just more habits. So I have my own conventions. It's not required that you follow them. I'll kind of show you by example here for a second, but if there's any evidence, it would be that generally I'm a complete slob when it comes to like real life. My wife has pneumonia this week, so I've been having to like take care of her and stuff. So I mean, I've found that I'm not good at that. I've had to learn how to like do dishes. I know. I didn't appreciate that woman. She almost had to die for me to, well, but the punchline here being is I'm a complete slob. I leave clothes laying around the house and stuff like that, but I actually take indenting and syntax structure seriously. If that doesn't prove it, it's important. Nothing will. So some textbooks, for the opening, closing curly brace, they'll put the opening curly brace up there for space saving, because every line costs an amount of money. And then a lot of students will take this as being the holy grail of the way to write it. There's nothing wrong with this. I like having this opening curly brace on the next line down so that you can clearly see where does my while loop start, where does my while loop end. And this is most helpful in situations where you might have many lines of code inside there. So it looks like a block structure. Nothing wrong with doing it the other way. Historically, I would say that maybe 9 out of 10 of my students that graduate, then go out and get jobs, write it the way I write it. You always get that one, loner goes against the grain. Okay, so while I is less than or equal to 10, what are we going to do? We'll talk more about the details of this later, but this is how you print crap to screen. I'm sure you saw it in your Hello World program. If you didn't, you found a C# example. If you wrote something like console.writeLine, that was C#. We'll do the Hello World joke shortly. Okay, so what does this do? Well, actually, this is an infinite loop right now. So this code prints all the numbers to the screen 1 through 10. So I have a variable named I, started off at 1. So I defined it once, started off with a value of 1 in there. Then I asked the question, while loops are pre-check loops. So while I is less than or equal to 10, the current value of I is 1. Is 1 less than or equal to 10? Yes, it's a true statement. So since it's true, I'll come into the body of the loop, I'll execute the first line, print out the current value of I. It prints a 1 to the screen. Then I becomes whatever I currently is plus 1. I is now 2. Spin back up, because loops repeat. We ask the question again. Is I less than or equal to 10? Is 2 less than or equal to 10? Yep, print out 2, 2 becomes 3. 3 less than or equal to 10? Yep, print out 3, 3 becomes 4. 4 less than or equal to 10? Yep, print out 4, 4 becomes 5. Five less than or equal to 10? Yes, it's equal to it. So we'll print out the 5. 5 becomes 6. Is 6 less than or equal to 10? No. So we'll fall past the end of the loop. We won't execute the body again. And we're right here after our loop. And we continue on with whatever code we have next. That make sense? Okay. So that is the, we'll do the less than or equal to 5. We print out, that's the print out the numbers 1 through 5 version of a while loop. Okay? What we're going to see with a for loop, because just like I said in the previous slide, I think it was the previous slide, right? While loops and for loops are very similar in how we solve problems because they're both pre-check loops. Really, the biggest difference between a while loop and a for loop in terms of syntax is all the extraneous pieces of a while loop kind of get sucked up into the header of the for loop. And what I mean by extraneous piece is like this starting your counting variable here, because remember, for loops lend themselves to counting problems. So the counting variable is built into the syntax of a for loop, as well as the changing the counter value. So this first line, int I equals 1, happened exactly one time here, right? Got the ball rolling. This increment value here, I equals I plus 1, this happened each time through the loop, right? For loops will take this piece and move it up into the header of the loop, this part. Okay, so it's kind of a compressed version of a while loop. I need to steal that. For loops. So for loops start off with the keyword for, opening parenthesis. Now there's 3 sections in here. Okay? The first section is var_def, let's just call it that for right now, followed by a semicolon. Second section is a Boolean expression. Third section is change var. And you'll see what I mean about moving everything into the header when I show you the example of printing out 1 through 5. Okay? So now let's write the printout 1 through 5 version of a for loop. So remember, 3 sections in our for loop. For int I is equal to 1, I less than or equal to 5, I equals I plus 1. So all 3 of those portions are in the header of the for loop. So what used to come before the while loop is now part of the for loop, and what used to come inside the body of the while loop is now part of the for loop. But everything executes in the same order. So for a for loop, this part right here happens exactly one time. And it's the very first thing that happens when we come into the for loop. So we define a variable name I, start off at 1. It doesn't have to be called I could call this dog if I wanted to. Okay, but for loops, typically I, J, K tend to be our counting variables. That's if you have a loop inside of a loop inside of a loop. 3 dimensions. After you get past 3 dimensions, our human minds don't do that well with 4 dimensions. So nothing keeps you having a loop inside of a loop inside of a loop inside of a loop except our logic breaks. You know, then we get into an infinite loop and somebody goes to the emergency room and it's just a mess. All right, so just like our while loop, all the parts are here. So this part right here happens exactly once and happens before we even check the Boolean expression. For loops are pre-check loops. So we ask the Boolean expression before we execute the body of the loop. So this happens next, I less than or equal to 5. Then we execute whatever's inside here. So I'll say system.out.println I. Then we do this last piece. Okay, so if I'm tracing through this, just like we did with the while loop, I come into this for loop, I create a variable name I, start off at 1. Then I ask the question, is I less than or equal to 5? Is 1 less than or equal to 5? Yes. Since that's true, come down here, print out R1. Then come and do this part. 1 becomes 2. Then ask the question, is 2 less than or equal to 5? Yes. Print out 2. 2 becomes 3. 3 less than or equal to 5? Yes. Print out 3. 3 becomes 4. 4 less than or equal to 5? Yes. Print out 4. 4 becomes 5. 5 less than or equal to 5? Yes. Print out 5. 5 becomes 6. 6 less than or equal to 5? No. Fall past the end of the loop. Right here. So everything happened in the exact same order, just the for loop version of print out the numbers between 1 and 5, just kind of compacted those pieces up into the header. That makes sense? And there's actually a convenience for that I'll show you here. Actually, let me show it to you now. Now is a pretty appropriate time for it. And then we'll come back and do the do while loop. Okay, so let's actually go and look at some code. I'll create a new So out of curiosity, for those of you who did your Hello World tutorial, how many of you used Eclipse as the example? Okay, what else do we use? How many of you use NetBeans? How many of you did it through the Java compiler at the command line using like Notepad or something as the, see, you appreciate how to write a Java program. See, well, that is actually interesting. So this is another history lesson, if you will. Eclipse. I'll show you where to get Eclipse here in a second. Eclipse is what's called an integrated development environment, an IDE, just like Visual Studio. It's a super-powered text editor for writing software, okay, specifically for Java. Well, before those things existed, you had to write your software using a text editor. So you probably, you know, a Mac or a PC? PC used to use Notepad.
At this time, I was at work, I would have used Ultra.
Okay. Oh, man. So she's trying to show off, like, oh yeah, we use Ultra Edit, you know, a real text editor. Okay, so now I'm going to show off for you. Have you ever used Unix?
No, I don't.
Okay, so we're going to use the VI text editor. Okay, VI text editor predates everybody in this room by a lot. Yes, even old text editor. This predates the mouse by a lot. Okay, mice didn't exist. That's why VI works the way it works. So we're going to write a program called, I'm going to say blah.java because I'm not sure what other programs I've written out here. So I'm pretty, you know, actually I use blah a lot. So it's chances are I have written. I have! Oh, here, Lauren will like this. We'll call it who.java. She's a big Doctor Who fan. All right, so I'm using a text editor. Now, first of all, when you first come in here, you have to go into insert mode. You have to issue commands to the text editor because I don't have menus. You know, the mouse doesn't work in here. This is out of the Unix console. This is if you were still writing stuff in DOS. So I'm going to press I to go into insert mode, and I'm going to say public class who. Public static void main string array args system.out.println. You could choose. Yeah, my MO typically is to do 2 spaces, and part of that's because I've been programming since I was 9. So I started off writing code like this, and because of that, as soon as you start writing really big programs, if you're always using tabs, your code's all the way off the end of the screen, right? So I use 2 spaces. To me, it seems like it's enough of an indent to see it. So kind of choose. What we'll see with Eclipse is they do the indenting for you, so you don't have to think about it. So kind of a benefit. So here's our Hello World program. I'm going to delete this extra I here. So I created a public class called who. Has to be the same name as your .java file is. That's something you would not see inside of Eclipse because Eclipse hides this from you. That's why I like showing you the old school way of doing this. So because I named my file who.java, I must name my class here who. Okay, so this is my Java class. Inside here, I have a single method called public static void main. The name of the method's main. All right, all programs begin and end with main. That should get ingrained in your soul. Because the comment I made last class is it doesn't matter what programming language you're using, right? I'll show you this here in a minute. So public static void main string array args. To save this, I pressed escape to go back into command mode, press W to write it, Q to quit. Okay, so I just typed that file. I just edited a file. So now to compile it, I'm going to use the Java compiler, Javac. If you're on a Mac, it's already on your machine. Java compiler comes with your Mac. If you're on a PC, you had to go to java.sun.com. which is going to take you to Oracle's website. So then go to downloads, Java SE7 update 51. That'll cut it. So click on that, and then you want the you don't want either of those. You want the SDK. Oh, JDK org. Oh, okay, so here's all your different platforms for it. So you choose the one you're for. So if you're Windows, x86, or x64, pretty much everybody has a 64 one now. That wasn't true 2 or 3 years ago, but it won't matter which of these two you choose. Download it, install it. I haven't done it in Windows in a while. When you installed it on Windows, did you actually have to set your class path? Okay. What ends up happening is when you go into Windows, after you install it, you just double click to install it and it goes and does its magical thing. If you then go out to DOS to do this, which you had to go out to the command prompt, it's not called DOS anymore, but it's emulated DOS. If you were to type in javac and press enter, it would say, I don't know what you're talking about. It's never heard of it. Even though it just installed it, it just didn't install it in one of the places that was in her path. That is one of the places it searches when you just type a command. So she had to update her path environment variable to include probably C:\\JDK, whatever, program, wherever it put it. Yeah, wherever it put it, the bin directory inside of there. So after she did that, then she was able to type in javac out here. So we're going to use the Java compiler. That's Java C, javac. And the name of the file we're compiling here is who.java. This takes it through the compiler. Should have just created Java bytecode for me. So we'll see if I do ls who star. We have a new file here called who.class. Okay, so that's the output of the compiler. So to show you where this lives in the big world here, if I scroll up, that's this guy. So I took my Java source code, who.java, I compiled it, and it spit out Java bytecode. Now, who interprets Java bytecode? The Java virtual machine. So now I need to go, and I need to call upon the Java virtual machine, which is just Java, and tell it to interpret who. And it'll use the who.class file. You don't put .class, you just say who. And it'll spit out hello world. Make sense? Okay, now some interesting things. vi who.c. As a reminder, here's our hierarchy of languages. Java's way down here as a grandparent of the C programming language. Make sense? Huh? I said no. Java has a grandparent, that is the C programming language. Did I? Oh. Well, look, you know, this is the year 2014. So, I don't even know what that means. Okay. What was I talking about? Oh, so we're going to write that same program in C. So remember, a few minutes ago I said all programs begin and end with main. So we're going to create, I'm going to do include standard io.h int main. Okay, so here is our equivalent Hello World program in the much older C programming language. Notice we also have a main method here. And this main method has some extra crap in here where Java had less extra crap, but still had some extra crap. Okay, we'll talk about what that extra crap is here in a second. And instead of system.out.println, we have this function called printf. to print out hello world. Make sense? Okay. So we'll go ahead and compile this. So we're going to go GCC. This is the GNU C compiler. And we're going to compile who.c. And this is going to create a file for me called a.out. And there's my hello world. A.out, that's actually an executable for the Mac. It's always a.out. Unless if I do GCC, I think you can give it a flag for what you want the name of the file to be if you want. But, you know, as long as you know it's a.out, then you can, for testing purposes, and when you finally get it the way you want it, and you want to distribute your software, then you'll name it to whatever you want to name it.
Can you do that one more time with the terminal on how you did it without the not the C but in the Java? Like how you just did that before a couple minutes ago?
To compile it?
Yeah.
Okay, it's javac who.java. So whatever the name of your source code file is, we're going to run it into the Java compiler, javac. So I'm pretty sure if you go out to your terminal, are you on your terminal on your Mac? If you do command spacebar and then type in term. Okay, just type in javac real quick and press enter. Just like that. Do you get a bunch of stuff spit to the screen like this?
Yeah.
Okay, good. It's installed. So there's proof that the Java compiler is installed. So you'd write javac who.java, then press enter, and that will compile it. And as long as it doesn't scream at you, then java who will run. And there's your hello world. Okay? So, back to our who.c. This guy has a main method. All programs begin and end with main. I promise you the C++ version of this would look pretty similar. It would say pound include iostream.h. It would say int main, int, here, I'll just show you real quick, because I'll give you the examples in int argc, char pointer argv, like that. Cout hello world. So that's the equivalent program in C++. This ends the line. Here, I'll throw the \n in there too. That's a carriage return line feed, \n. All right, so that's the C++ version of this. Now, interestingly enough, if you're looking at the these languages as they evolve, what did we add up here? We took away an asterisk here and added the square bracket thing here, right? Look at the Java version of see the square brackets? So you kind of see how it's evolved. It's the same language. C was upgraded to C++. C++ was upgraded to Java. Yet at the lowest level, and even at the medium level, these primitive types and variables and loops, it's all the same. Literally identical. Okay? Now, let me give you the punchline for this right now, and we'll take a break. Okay, because we're already past 8 o'clock and I have to pee. So, what is this stuff up here is the question. Back in the day when we didn't use integrated development environments or didn't have graphic user interfaces where we double-clicked on icons and crap like that, our programs used to take command line input. Just like the Java compiler. It expects us to tell it the name of the file we want it to compile. So, I'll quickly write a little loop here. For int I is equal to 0, I is less than arg, well, I called it arg. Most examples see, we'll call it args here. But I'll actually call it elephant. Just to prove it doesn't matter. That's just a variable name. So whatever you call it up here is how you need to use it down here. So, and this is more trivial knowledge what I'm giving you right here. Not that important because you hardly ever use it, but you always have to write it. Because the main method always takes in string array something. It's a requirement. And I'll show you the punchline here. So I is less than elephant.length. I is equal to I plus 1. So what does this guy do? When I run this program, it's going to loop through, start I off at 0, keep going as long as I is less than however many things are inside elephant. Elephant is something called an array, which we'll talk about probably in a couple of classes. So don't worry about it too much now, but it's a collection of things. Okay? So this is the number of things inside of elephant. And each time through we'll increment I by 1. And what are we going to do? We're going to print out whatever is in elephant. Whatever value is currently in there. And to show you that punchline, I'll save this. We'll compile it. We'll run it. And when I run it now, nothing will show up. Nothing, right? But now I'll run it, and afterwards I'll give it some command line arguments. Java who A, B, C. It prints out my A, B, and C. So that's my way of sending input into my program from the command line. That's left over from C, where that used to be very commonplace. Okay? Then it was handed down to C++. It was handed down to Java. You can still write command line programs in Java. We just did. But it's not nearly as common today as it was in the 70s and 80s. When that's how programs were written. Now we're used to just double clicking on them and they pop open and where to get its input? Well, probably when you first open a program, it asks you for username and password, or, you know, please enter these 4 pieces of information. Where historically I might have said this, who/you Mike for username -p blah for password. That might have been the input I gave it. Ran it, and it would read those things in and done something with them before the program actually started displaying stuff to the screen. That make sense? All right, questions about any of the crap we've talked about up to this point? All right, so let's take about a 15-minute break, come back at 8:20, and we'll pick up with loops. We'll just kind of pick up where we left off. I'll get this video uploading. Sound good? All right.